Hello, my name is Peter Parker, and I am a principal scientist at Caliola Engineering. I will be talking about our low-cost and novel solution for position, navigation, and timing in a GPS-denied environment. The Navy desires a resilient and robust solution to their navigation needs, especially when the GPS signal becomes unavailable or denied. Caliola has a software-based solution which interfaces with existing satellite communication and PNT systems. Caliola is a woman-owned small business that pairs PhD researchers with military operations experts to deliver innovative technical solutions to the Department of Defense. Our core business areas are to provide reliability and security in the related fields of communication systems and alternative position navigation and timing systems. Our staff provides subject matter expertise in PNT systems, wireless communication systems, cryptography, protected MIL SATCOM, software-designed radio, and unmanned airborne systems. We have provided systems and support for organizations in the Navy, Air Force, and Space Force, as well as the Missile Defense Agency. We have also successfully partnered with original equipment manufacturers to provide them with our highly qualified subject matter experts on various programs. The Navy is looking for solutions to enable GPS-denied position, navigation, and timing that do not require the development of additional hardware. This constraint suggests the use of existing satellite communications infrastructure to provide the means to back out a ground position for that equipment. This technique, termed SCAP, or SATCOM Antenna Pointing for Positioning, is a software-based solution that utilizes the Navy's open architecture standards to tap into the data stream of the satellite communications terminal to extract pointing data. The output of the SCAP system then interfaces with the Navy's GPS positioning, navigation, and timing service as an accurate GPS alternative source for positioning. With GPS being integral to the operation of many DoD systems, there is a vulnerability to situations where the GPS signal becomes unavailable or denied for extended periods of time. The low-cost SCAP software provides a solution that uses available signals from existing shipboard communications infrastructure to provide an alternative source of accurate positions to GPNTS to aid in the navigation of a ship. This software is readily customizable to other platforms and can be modified to interface with many different SATCOM terminals and navigation systems. A few examples of transition opportunities include Defense Advanced GPS receivers, mounted positioning, navigation and timing systems, and the Naval Computer and Telecommunications Stations. Caliola is currently on contract with the Navy to produce a prototype of the SCAP system that will run on Navy ships. The SCAP software will interface with an onboard SATCOM terminal to read out the measured angle between the ship and the satellite that the terminal is communicating with. This angle, along with the known location of the satellite, is used to back out the position of the ship. The software is written in a modular format to allow for easy changes to interfaces without having to change any of the core algorithm. This will allow for minimal changes to the code to interface with other types of SATCOM equipment. To get an accurate position fix out of the SCAP algorithm, the research and development required for this includes ways to accurately calibrate the various data source components in the system, including the antenna pointing angle, the INS system biases, the satellite ephemeris errors, and any tropospheric refraction effects. With these calibrations in place, an accurate position solution is then presented to the ship's navigation system. In our current Navy contract, Caliola is working to provide a Technology Readiness Level 6 prototype that is demonstrated in an operational environment. This prototype will be capable to work with multiple types of SATCOM terminals to provide an accurate GPS-denied position solution. As of the end of calendar year 2022, Caliola has a lab prototype completed and has begun to show performance of the system using relevant data in preparation for the next major demonstration in September of 2023. As with any alternate position navigation and timing system, SCAP will enable navigation within a GPS-denied environment. In addition, the SCAP system generates an estimate of the position that is independent from the GPS solution, so it will provide additional information to detect GPS spoofing. The SCAP software will also be able to be integrated into any existing navigation fusion engine. The main transition target for the Small Business Innovation Research Program is the Navy's GPS-based Positioning, Navigation, and Timing Service, or GPNTS, program of record. Beyond the naval surface ship application, there are many other opportunities for application of this technology. Other surface ship applications include the Coast Guard, foreign military sales, or MDA mobile sensor platforms. Land-based mobile platforms that also include a SATCOM terminal are great candidates for this technology as well. Caliola is currently working on the prototype SCAP system with the goal of transitioning this technology into the Navy's GPNTS program of record. This will allow us to establish a stronger presence within the alternate PNT community. However, there are many other platforms within the DoD or other federal agencies that have needs for GPS-denied navigation that Caliola's technology can help with as well. Also, in an increasingly uncertain world, commercial trucking and delivery companies may start looking for inexpensive solutions for GPS-free navigation. Caliola is well positioned to meet those needs in the future. The SCAP SBIR program is enabling Caliola to do the research and development for alternate PNT solutions. While our first SCAP product is tailored towards a Navy surface ship, there will be minimal changes to the software to support similarly configured platforms. In other words, platforms that include a SATCOM terminal and a navigation system. Looking forward to SCAP extensions, we will soon be working on a variant of SCAP that uses multiple constellations of satellites to derive the location position. That is, not only the geostationary communication satellites, but also constellations of low Earth orbit satellites such as Starlink or similar constellations. As this SCAP technology matures, we will also look forward to providing standalone systems that do not require the use of pre-existing hardware or a system that can provide hardware for the dual use of satellite communications and positioning. That concludes our presentation, and all of us at Caliola Engineering thank you for your time watching this video. Please do not hesitate to reach out to any one of us listed here with any questions you may have about the SCAP technology or about Caliola in general.